Good morning, students. Today I am going to discuss the topic the structure of atoms. The structure of atoms. As we know that atom is the smallest particle of a substance. So let us first know how to find the structure of atoms. So many attempts were made by the scientists to draw the atomic model, in which the first one was J. Thomson's atomic model. According to J. Thomson's atomic model, an atom is supposed to be compared like a watermelon. As the pulp of watermelon is red and black seeds are embedded in it. In the similar manner, the mass of atom is said to be positive charge, and some masses of the atom as compared to the seeds of the watermelon are embedded in the masses of positive charge in such a way that the net charge of the atoms becomes zero. So this model and J. Thomson's atomic model says an atom is like a watermelon. The red pulp of the melon is like positive charge of the atom, and the seeds embedded are like negative charge, the masses of positive and negative charge are distributed in such a manner that the net charge is zero. This is what J. Thomson's atomic model says. According to this model, the masses of atoms are uniformly spread in such a manner that the net charge on the atom becomes 0. After the attempt of J. Thomson, another scientist, Rutherford, also produced his atomic model that was called Rutherford's atomic model. But before we discuss the Rutherford atomic model, let us first of all know about the radioactive elements and the rays that they produce. Radioactive elements. Radioactive elements are actually those elements which continually produce some rays randomly. These rays were discovered by Henry Becquerel. The rays were discovered by Henry Becquerel. In 1898. Henry Becquerel discovered this ray. This is a story as I have heard. Henry Becquerel had a very small dark room in which there was a cupboard, actually almirah. In that almirah, a camera roll was already placed. One day, Henry Becquerel brought a packet of uranium and placed it in the same almirah along with the camera roll already placed there. After some days, when he went to take the camera roll, he found that the roll was disturbed. It has gone out of order. As we know that camera roll is coated with a chemical called silver bromide. When silver bromide comes in contact of light, it changes into silver and bromine gas. Henry Becquerel thought, how did it happen? As there was no light in the room, even the camera roll was captured in the cupboard. There was no possibility of the light entering there. Yet the camera roll has got some changes. So he took that uranium pocket into his laboratory, and when it was examined, it was found that some of the atoms of uranium had got changed into thorium. Actually, the light that emerged was from uranium that defected the camera. When this idea came in the mind of Becquerel, the rigorous experiment was done regarding this, and it was found that the heavy elements continually produce some rays, and due to their production, the atoms get changed. These rays were called Becquerel rays because these rays were discovered by Henry Becquerel. Their names were, the Becquerel rays were Becquerel's rays were alpha ray, beta ray, and gamma ray. Abbreviately, alpha ray was written like this, alpha. Beta ray like this, beta ray, and gamma ray like this. These rays are generally produced from the nucleus of the heavy atoms. The nature of these rays, alpha ray and beta ray particularly, were discovered by Rutherford. According to Rutherford, alpha was a positively charged particle, beta was a negatively charged particle, and gamma was neutral. Actually, gamma is not a particle, rather it is only a wave. Alpha particles, alpha ray is positively charged, beta ray is negatively charged, gamma ray is neutral. The charge on one beta particle, one alpha particle is 2 unit positive charge. We must know that 1 unit charge equals 1.6 into 10 to the power of -90 coulomb. Coulomb is the SI unit of charge. Beta particle has 1 unit negative charge. Charge on beta particle is 1 unit negative charge. Charge of beta particle is 1 unit negative charge. There is no charge on gamma particle. So, the nature of the Becquerel rays, also called radioactive rays, was discovered by Rutherford. So, before the production of Rutherford's atomic model, Rutherford already knew about the nature of the radioactive rays. What was Rutherford's atomic model? Let us proceed there. Rutherford's atomic model. Before representing his model, Rutherford did an experiment which was called alpha scattering experiment. Rutherford's alpha scattering experiment. Rutherford's alpha scattering experiment. According to this experiment, a very thin sheet of gold was taken. It is actually a foil, very thin, and a sheet was placed behind it, coated with a chemical known as zinc sulfide ZnS. Zinc sulfide actually is a fluorescent material. When light falls on it, it shines. Therefore, Rutherford put a sheet behind the gold foil, coated with fluorescent material zinc sulfide. He bombarded many alpha particles on the gold foil. And found most of the alpha particles crossed the gold foil without any deflection. Some got deflected. 12,000 alpha particles rebounded, that is returned on the same path. So after doing the experiment, Rutherford observed three things. Number one, most of the alpha particles crossed the gold foil without any deflection. A few alpha particles got deviated when went near the foil. One of 12,000 alpha particles receded the path, it means returned on the same path. So this was the observation that Rutherford found. After this observation, Rutherford came to a conclusion, and his conclusion was, what was his conclusion? As most of the alpha particles crossed the gold foil without any deflection and without any change in its speed, Rutherford came to the conclusion that the atom's mass is not uniformly spread, as it was said in J.J. Thomson's atomic model. If the masses of atom had been distributed uniformly, then while passing the atom, the speed of alpha particles must have some changes. But actually, alpha particles cross the gold foil without any deflection and without any change in its speed. It was clear that most of the space in the atom is empty. This was the first conclusion. This was most of the space in an atom is empty. Second conclusion, a few alpha particles got deviated. This means a few alpha particles got deflected when went near the gold foil. As we all know that there is repulsion between the similar charges, there is attraction between dissimilar charges. So alpha particles got repelled by the positive charge inside the atom. because alpha particles were positively charged. It was already known, and as there was a repulsion due to which alpha particles got deviated, it meant that there is positive charge inside the atom. But this positive charge is not spread throughout the atom, as had been dictated by Thomson. This positive charge is actually concentrated at some space. And the next conclusion, one alpha particles out of 12,000 rebounded the earth. It means the whole mass of the atom is concentrated at a very small space inside the atom. This space was called nucleus. It means whatever the positive charge is in an atom is concentrated at the nucleus. But it was also known that the atom is neutral. It means that there must have been some negative charge. What was the role of the negative charge? Actually, the negative charge, which we now call electrons, are distributed. They are not united at a place, but positive charges are concentrated at a place, means they have unity. So the repulsion of alpha particles was more than its attraction by the negatively charged electrons. It means there was net repulsion in the alpha particles. So in a nutshell, we can say about the conclusion of Rutherford that their conclusions are as follows. Number one, most of the space inside an atom is empty. The whole mass of an atom is imagined to be concentrated at a very small space called nucleus. The negative charge are distributed in the atoms. The nucleus is positively charged, and this nucleus, which is positively charged later on, not by Rutherford but rather by Goldstein, that the positive charge as protons. Madame Curie discovered that some neutral particles, neutrons, are also found in an atom. So, on a whole, we have three subatomic particles inside an atom. These subatomic particles also called fundamental particles, are electron, number one electron, number two proton, and number three neutron. These three particles are called fundamental particles of an atom. In the nucleus, protons and neutrons are found, so they are also called nucleons. Protons and neutrons altogether are called nucleons because they live in the nucleus of an atom. So this was Rutherford's atomic model, but in this model there was some drawback. Rutherford had said the electron move about the nucleus. He had imagined an atom like a miniature solar system. the nucleus compared as the sun and the electrons moving about the nucleus on the different paths called orbit, like the planets which move around the sun on different orbits. So according to Rutherford, the negatively charged particle electrons move about the nucleus. But there had been a discovery yet in the past in 1870 by Maxwell. His discovery said if an accelerated charged particle moves, then its energy continuously decreases. And if this is the case, the electrons moving about the nucleus, which is an accelerated motion due to change in its velocity, should also lose energy, and a time should come when nucleus should fall in the nucleus. If this had happened, there would have been no atom, and the imagination of substances, this world, would have been a false statement. Actually, the atoms exist, electrons move, but there is contradiction in the explanation of the theory. Rutherford also did not fix the number of electrons if an atom has more than one electron. He did not fix how many electrons moved on which orbit. This was also supposed to be a drawback or anomaly of Rutherford's atomic model. But this drawback was corrected by Niels Bohr. This drawback was corrected by Niels Bohr. Niels Bohr was also a chemist. According to Niels Bohr, the electrons yet move about the nucleus in an atom, but they don't move with their own energy. Rather, they receive energy from the orbit, and by that energy they move, so there is no chance of them to fall in the nucleus. Another drawback regarding the fixation of number of electrons on different orbits was also removed by Niels Bohr by repeating a formula 2n², where n is the number of orbits. In first orbit, the number of maximum electrons should be 2 into 1 square equal to, by putting 1 for n, because n is the number of orbits. If you want to find the maximum number of electrons in the second orbit, we should fill 2 for n, then it will become 2 into 2 square equal to 8. It means the maximum number of electrons in the second orbit should be 8. Similarly, in the third orbit, the maximum number of electrons should be 18. In the fourth orbit, the maximum number of electrons should be 32, and so on. First orbit was also called as K cell. Second orbit was called L cell. Third orbit was called M cell, and so on. In this manner, Niels Bohr removed the drawbacks present in the Rutherford's atomic model. So, students, in the next class, we will learn the electronic configuration of the atoms. Thank you.